This is for Year 12 methods. It comes out of Chapter 1H, so Applications of Functions, question number 3. We'll see how we go along the way, but it's probably a technology allowed question. Most application questions would be, because sometimes the mathematics becomes messy. Okay, the dimensions of an enclosure are shown, so I can see on the map over there, the perimeter of the enclosure is 160. Okay, so I can get an expression already that 160 will equal all of the side lengths. Now, it's all got right angles. So the perimeter is identically the same as x, y, x, y. So 160 equals 2x plus 2y, which means 180 equals x plus y. If I want x equals, it's 180 minus y. If I want y equals, it's 180 minus x. How do I know that if that's y, then this bit here and this bit here, this bit must be y minus 20, and 20 plus y minus 20 is y. And since this bit is 12 and this is x, this is x minus 12, and this plus this will also give me x. Okay, so there's an expression that I have in terms of x and in terms of y. What else do I know? That's x minus y. So, okay, so find a rule for the area of the enclosure in terms of x. So I'm going to replace y with this, and then I'll have it in terms of x. So my area is going to be, depending on where you put your lines, I'm going to put one there. So I'm going to have y times x minus 12 plus 12 times 12 times 20. So y is 80, not 180. I divide it by 2. So 80 minus x times x minus 12 plus 240. 80 times 12. 960 negative 960 plus 80x plus x minus x squared plus 12x plus 240, and that equals minus x squared plus 92x minus 720. I'm thinking that there's probably not going to be a nice answer. See the awful numbers. Okay, state a suitable domain for the function. Okay, how I'm going to find the domain often is having a look over here. Y and x both have to be bigger than 0. Because I have this, y minus 20, y is going to be bigger than 20. Because if y was 19, then that would make no sense. And with this here, x is going to be bigger than 12, because it would make no sense if it was less than 12. This here tells me that y can't be bigger than 80, and x can't be bigger than 80. But x plus y added together equals 80. So if y can't be less than 20 and x plus y is 80, therefore x has to be less than 60. So I know that x has to be less than 60. And the reason it's 60, not 80, is that y can't be less than 20. And x has got to be bigger than 0. Therefore, my domain is 0 to 60. Sorry, 12 to 60. Sketch the graph of a against x. Oh golly, this isn't something to do by hand. I know my discriminant's going to be 92 squared minus 4, so minus 4 times 1 times 720. That's not nice. I know my turning point is at minus b over 2a, which is 92 over minus 2, which is 46. So I know my graph looks something like that, where that's 12 and that's 60 and that's 46, and that's where the maximum is going to be, but I'm going to use my calculator to actually come up with it. So what have I got? I'm going to take that, drag and drop. I'll just have a double check. Can I factorize this? Interactive transform, factor. I'll see if there's nice numbers. No, there's not nice numbers. So I'll take that into a new line. Not selected all. Transform factor, R factor, and it tells me that there's thirds involved. I'll never be able to do this by hand. So I'm going to drag and drop. I'm going to change my window from 12 to 60. I'm going to do zoom auto, and there it is. And I can do analysis, gsolve, ycalc when x equals 12, and that gives 240. Okay, I might just pause this for 1 minute. Okay, I can see that it's 12 and 240, and the graph looks like this. So I might go up here and bring this down and do interactive, bring up my keyboard, math 3 given x equals 46, and also I want an endpoint which would be 60. So 1200. So my graph needs to go up to 1400, and okay. 2, 4, 6, 8, 10, 12, 14. So 60 and 1200, 46 and 12 and 242, 4, so 240. 60, 46, 12 and 240. Can't remember the numbers. 1396. 1200. So there's my graph. I have coloured in circles at my endpoints because I had square brackets on my domain. Find the maximum possible area of the enclosure. So the maximum possible area of the enclosure will be 1396 meters squared, and that's when x equals 46, and since x plus y equals 80, y must equal 34.